Hello everyone, and thank you for joining us for today's Sensafili Sparring Partners webinar on simplifying 5G deployments with cluster connectors. This webinar has been sponsored by CommScope. We have a full panel of speakers today. Our debaters are Martin Zimmerman, Engineering Fellow of Outdoor Wireless Networks for CommScope, Sebastien Roy, Marketing Director at Radiall, Earl Lum, President of EJL Wireless Research, Omar Parimbelli, Product Line Manager for HELIAX at CommScope, and Monica Paolini, Principal at Sensafili Consulting. I'm Kendra Chamberlain, and I will be moderating our webinar today. In Sparring Partners webinars, we watch debaters discuss a topic and answer your questions on video. We would like to encourage our audience to participate in the discussion. Please share your comments and questions using the Q&A box at the bottom of the Zoom screen. All comments are visible to all participants, so please keep the conversation polite and respectful. Our debaters will do their best to address questions as they go along and as they become relevant to the topics being discussed, so please do not hold your questions until the end. We have posted links to a few related resources. You can find those in the chat window, which is accessible via the chat button at the bottom of the Zoom screen. And finally, we will be live tweeting the webinar today. You can follow along or participate in the discussion on Twitter using the hashtag #SparringPartners. And with that, I'll hand it over to Monica.
Kendra, thanks a lot for the introduction, and it's a great pleasure to be here to talk about connectors again, because we did the first session yesterday, and since this is live, we're going to cover pretty much the same ground, but I can promise if you were in the previous one that it's going to be somewhat different. Connectors, it's really an interesting cluster connectors. It's a very interesting topic, and you will see throughout the webinar, I hope, because it's really, we'll really get into the roots of what makes 5G reality possible and manageable. More importantly, so we often tend to think about the sort of the, what's the greatest thing about 5G. But at some point you have to deploy. You have to deploy it in a way that is cost effective, doesn't drive you nuts, and it works. And this is where connectors play a very important role. So we will go into much more detail about it, but before we do that, I would like to ask our debaters to introduce themselves, and then we will go on and talk and answer all your questions. In the panel, in the Sparring Partners we did yesterday, we had a lot of questions, and so feel free to ask questions, comments, but don't wait until the end because we do not have a final Q&A. So just go ahead, ask your questions as you want, and then as they come to your mind, and then we'll deal with them as soon as possible. Said that, I'm going to go through the order of the people I see on the screen. So Earl, you are first. You want to introduce yourself?
Sure. Thank you, Monica. My name is Earl Lum. I'm president of EJL Wireless Research, and we are a market research and consulting company. My area of focus is on antennas, radios, base stations, and semiconductor components inside those systems, as well as fronthaul and backhaul. So essentially anything that's bolted to a tower or rooftop, we look at, we analyze, and we provide consulting and market researchers for. Thank you, Monica.
What about if they are not on a rooftop, or what about they're inside?
If they're on a pole, then yeah, we're not talking about small cells today, so I'm going to defer that for another time, and we're not talking about indoor DAS.
Sorry, I just couldn't help it. Omar, how about you?
Hey, hello everybody. This is Omar Parimbelli from CommScope. I am product line manager responsible for HELIAX in Europe, and today I'm here to talk about M-LOC and show M-LOC to you.
Excellent. Sebastien.
Hello everyone, good morning, good afternoon. I'm Sebastien Roy. I'm working for Radiall, a leading company who design and manufacture connectors. I'm leading the marketing, product marketing strategy and business management. And I'm here, because M-LOC is using Next10, and we are part of the Next10 designers. Yeah.
Excellent. And Marty.
Hi, my name is Marty Zimmerman. I am an engineering fellow and I work in the Outdoor Wireless Networks segment at CommScope. My background is base station antenna design. I've done that for about 25 years, but now I represent all the groups inside Outdoor Wireless, which includes not only antennas and filters, but also cables and connectors.
Okay, cool. So let's get started and talk about cluster connectors and I guess connectors in general. So I guess that the main issue that we're facing with 5G is that, yes, we get much better performance, it's the great technology and all that, but there is no free lunch. So 5G comes with increased complexity. You have higher order MIMO, you have more antenna ports you're dealing with, and that's only one part of the issues, but networks are more complex and we need to find a new way to manage them. Otherwise, you end up not being able to get the benefits of the technology. And so maybe I can, whoever of you wants to start talking about why is it that connectors are always important all the time, but why are they becoming more important as we move to 5G? What are the issues? Maybe, Marty,
so
go ahead.
I think the fundamental issue is from a zoning leasing perspective. People cannot put up more antennas. They cannot put up bigger antennas, but we're seeing like a geometric progression in the number of connectors. And so there's three issues. One, there are more and more frequency bands available. Some operators in some countries have as many as 10 different frequency bands that they might have licenses for. Secondly, and this really started in 4G, is the movement from 2-port radios to 4-port radios. So that potentially doubles the connector count for all your existing bands. And then third, the introduction of TD bands that are relying on beamforming. So in that case, you need 8 RF ports plus a CAL port, so that's 9 ports per radio. And so just in 2019, last year, we started the year by introducing a macro antenna with 30 ports, and by the end of the year, we had also introduced a small cell antenna with 30 RF ports. So the number of ports has just exploded in the last couple of years.
Yeah, and if you think about being the person that actually has to go and put it together, figuring out where everything goes, and it's just very easy to make a mistake. It's very difficult to to fix problems. So everything becomes much more difficult, time consuming, and prone to error if you have to the higher number it is, clearly.
Yeah, and I guess that so let me jump in, Monica, and I guess that maybe Marty can also help us to better understand what happens when we have a wrong connection in an AT guitar antenna. So I guess Marty will lose all the benefit,
Yes.
to an AT guitar antenna.
So
yeah,
that's a great point. So when you talk about a 2-port radio, 4-port radio, they rely on MIMO. MIMO assumes decorrelated signals. In theory, the antenna is designed so all 4 ports have decorrelated signals, so it really doesn't matter what order you connect them to. The main point is making sure the radio is just connected to ports that operate at that frequency band. With beamforming, each set of 4 ports is supposed to use correlated signals to form a beam with, say, better performance. And so there's going to be a phase progression, possibly an amplitude progression between those 4 ports. And so it's critical that the radio is connected correctly for every single port between the radio and the antenna. And then the final part being, you also want to make sure that you don't cross-connect the CAL port, because if you switch the CAL port with an RF port, the radio won't work and you may damage the antenna.
Absolutely. And when you think about it, so from a theory, from us talking about it, it makes perfect sense. And you think, well, fine. But if you are an installer going out there and doing the installs when you have operators having different configurations in different cell sites, I mean, that is very difficult to articulate a message. I mean, to explain to them what is that they need to do. I mean, the practicality of it is just really challenging, right?
Yeah, if you look at 4G operators that have deployed AT8R beamforming with standard connectorization, a lot of them, when they've done audits, have found a very respectable percentage of their, non-negligible percentage of the sites had been wired incorrectly. So it is a real problem.
So it's even with 4G, we don't have, it's not just a 5G issue.
It is a 4G issue. I would say it's actually more of an issue in 5G. Without getting into details, to a certain extent, miswiring a 4G antenna at TM8 is self-correcting. Miswiring a 5G radio to an antenna is a complete disaster.
Right. Okay, why don't we go with the first poll that about the current situation, and we can talk about what's coming next with the cluster connectors. So Kendra, could you start asking, ask the first question for the poll?
Yes, our first poll. What are the main challenges in installing an increasing number of antenna ports in today's deployments? We have cable manageability and limitations in space, training of installers, installation time, mating issues and reliability, or performance and PIM.
Okay, well, so actually, as the people, we give people time to vote. Earl, I know that you always, as an analyst, we typically count and look at things, but you had some more direct experience on this. Do you want to?
Sure, absolutely.
So we start talking about the cluster situation as well.
Right, and I can talk about my experience with the M-LOC product, and then maybe Omar can actually give a demo to show how it actually works, since I don't have one of the physical units with me anymore. But essentially, my experience with it has been to test the M-LOC against other connectors.
Sorry, before you do that, can you just talk about the this general concept of the cluster connector? We haven't started.
Sure. So definitely, if you look at what Marty was saying about having 30 ports on a faceplate at the bottom of an antenna, and assuming that they're all 4310 connectors, at this point in time, you will have essentially, if they're single connectors, you will have 30 jumper cables extending from the bottom of that antenna unit going to all of the respective radios and frequency bands. And connecting and taping and weatherproofing every one of those connectors is going to be a substantial amount of time and effort in order to do that. And you're going to have to try to figure out how to get your torque wrench in between every one of those connectors to be able to do that properly and to make sure everything is sealed. So if we're going to be in this 30-port world, the reason for the cluster connector is obviously to reduce the number of those ports. And if we assume that everything in 4G and starting off in very simplistic 5G is going to be 4T4R radios, then by natural assumption, you can go with a cluster of 4 connectors and reduce the 30 down to maybe 7 or 8, depending on, again, the total number that you need. But in terms of TDD, you can then have a 4 cluster connector and a 5 cluster connector to account for the calibration port. So it's really about simplifying and getting your hands, depending on how big your hands are, in between every one of these connectors, weatherproofing them, and making sure that everything is actually installed correctly is an incredible amount of time. And having done that in a case where I was trying to compare the ease of installation, I can absolutely tell you that installing an M-LOC connector takes about 30 seconds. Installing a 4310 and taping everything or another type of connector will take 15 minutes potentially, at least for me, because I haven't done a million of these connectors and I'm not an expert in it. But even if you got it down to 2 or 3 minutes, it's still 5x the time it would take just to clip something in and lock it into place.
Yeah. Well, and that's really, it's really important to think about those details. How long does it take? That's really crucial to the, when you go to scale and deploy a large network. Okay, Kendra, why don't you tell us what the audience think about the deployment challenges?
Okay, our results are cable manageability and limitations in space received 44%, performance and PIM received 33%, training of installers received 11%, installation time received 7%, and mating issues and reliability received 4%.
Excellent. Is that what you guys were expecting? And actually, maybe we can comment a little bit about performance and PIM. We haven't really talked yet about that.
Well, I would say that, starting from limitations in space, just closing what Martin said. So seeing that now on the antenna plates, the ports number are growing day by day, limitation in space is going to be extremely important. And I can maybe just show you, in terms of dimension, the difference of having a cluster connector versus a standard 4310. You see, here with the cluster connector, we may have 4 connectors in the space of basically 2 4310. Okay, so in terms of space saving is really amazing. Then the other thing is about performance. So I would link performance to what Martin just explained to us about the fact that would be a complete disaster if the connection is not done properly. Okay, therefore, if we want to link performance to the fact that using a cluster connector, you basically are sure that all the 9 cables, including calibration, as Marty said, are properly connected. Well, I think that definitely cluster is the answer to the issues that we have just seen.
Yeah. So
I think, I just said performance is like table stakes. That's a given. You must have that. It's a non-negotiable thing, and that's one of the reasons when we designed the M-LOK, we chose to base it on the Next 10, and maybe Sebastien could talk about what the features are of the Next 10 that makes it a good choice for a cluster connector.
Absolutely, yes.
Oh yes, absolutely.
Yeah, Sebastien, what can you tell us a little bit about what are the options, why Next 10, and where are we going with that?
No, exactly. I mean, the purpose of Next 10, and which has been created, by the way, a long time ago, 3 years ago, even more, at all the purpose. And if we think about simple, I would say, natural low constraints, we want to have more power, we want to have more performance, but in the reduced space. And then it becomes very difficult because, when we talk about radio frequencies, sometimes we really need to innovate how to do more in a smaller space. And of course, Next 10 is the right choice, to build this the cluster connector, because from the beginning it has been designed in order to do more, and when we talk about 4.310, for instance, is to reach similar type of performances than the 4.310 in terms of PIM performance, in terms of reliability, in terms of power management. Initially, of course, designed for a single connector, but now I'm very pleased to see that this connector and the RF performance can be centralized, gather all together in one cluster connector.
Yeah, can you tell us a little bit about, so whenever you get to anything that connects to anything else, it's important that we don't have too much of a fragmentation, too many options, that is an open standard, and all those kind of things. How is that? How do you approach that with the Next 10?
Yeah, of course. I mean, we know all outdoor market for us from a Radiall perspective, so the receptacle on the antenna, the plug on the jumpers. This is something that must be standardized, where multiple suppliers can manufacture and of course serve the end customer. That's something taken into account from the beginning, and Next10 is becoming an IEC standard product, and that can be accessed by many suppliers. Absolutely.
Yeah, and that's also part of NGMN specs for connectors, right? What's going on there?
Oh, for the Next10 specifically, you mean, or the M-LOK?
Yeah, or
Next10?
yeah. What is the sort of standardization part work being done there?
So I guess that if we talk about NGMN, maybe more up to speed. So yeah, exactly. So in this very moment in NGMN, we are discussing about selection of the standard cluster connector for FDD as well, of course, because TDD brings some technical issues. FDD brings different technical issues than TDD. Therefore, now what is ongoing in GMN is the so-called phase 3 for the selection of the cluster for FDD as well. I guess that the plan is to complete all the activities by the beginning of 2021. And for sure, M-LOK is definitely a candidate. And I would say that moreover, it's not only like that, but we also already see customers, that are successfully already looking at it for not only for TDD application, but also for FDD.
Yeah, absolutely. Now, Omar, you only showed us part of your demo.
Yeah, I was just trying to find the right slot to do it, because sometimes, I guess that pictures or images are often, clearer than many words. So forgive me, I will now move my my camera. Okay, so I can better show you also. Okay. Let me try. Okay, basically what you can see here is bottom on antenna. Okay, as Earl said, fasten a connector takes a little bit of time. Of course, you need a torque wrench, okay, to do that, and more than probably, as you will, do something so to be sure that there will not be any water intrusion before, cold shrinking or taping, anything like that. Okay, what we thought to do with M-LOK is something different and better, of course. So we said, okay, we want this to be, we want to be sure that all the connection will be properly done. Therefore, the cluster is designed with two shapes, 4 ports and 5 ports. The external ports are all RF. The 5th port in the middle is the calibration. And as Marty explained to us, it's extremely important that we don't mix also this one. Okay, that said, the footprint is designed so that, of course, you cannot mix the 4-port cluster into 5 ports and vice versa. Okay, so this is about the parts to ensure that the connection will be properly done and actually impossible to be mistaken. Okay. The other thing was we have to do it quickly, because otherwise it will take ages to connect each and every of this one. So we come with the idea of the M-LOK that is definitely very simple. So it's just to fit the connector in the position, okay, and then using this latch and fingers only, fasten it, and that's done. Okay, so now I've connected 4 ports in 3 seconds, I would say. Okay, the removal is of course not so easy because otherwise this would not be reliable, but can be done with a simple screwdriver. So actually no tools are needed so to do that. Okay, you just need a little bit of strength in doing this activity. So, and last but not least, that's the other important thing. Once this one is connected, there's no need for any other weatherproofing. Okay, so no cold shrink, no taping, nothing. It is what it is. So the connection takes few seconds, as you have seen from this live example, and does not require any extra work. Ensure that the connection is properly done from a mechanical and an electrical perspective without any tool, okay? And yeah, we think that's definitely a good product, I would say.
Hey, Omar, I see that there is a question that I think we should ask right away is how strong is the latch if larger, heavier cables are used from base stations to antenna?
Oh, okay, okay. We have, oh, let me now go back with my face. Maybe you prefer analog? No, so we have two type of cables, okay? This one that is 1/4 inch cable, and then we have also the version with the 3/8. Okay, that brings actually very good attenuation performance, better than 1/4 inch. The latch is always the same, okay? And because when you fit the connectors into the antenna, it brings a little bit of retention that allows you to remove the hands and do this kind of job. Actually, if the antenna is fastened on a pole, as you can see in the video that we have in our web on CommScope.com, you will see that for the installers, just use one hand and then with the other hand fasten it. And it's exactly the same with both the cable size version.
Yeah.
Hey, Omar, there was also a question regarding the number of cycles, or maybe Mari, you can answer that as well, is how many mating cycles can you use on the M-Lock?
Oh, yeah, well, that's a good question. Well, actually, we think that on the field that there's this connection and mating and the mating will not happen so often. Anyhow, for sure, you can do tens of times, more than 50 times without seeing any degradation. I really don't expect this to happen on the field, to be honest.
Oh, 50
And I might take
yeah, there is a bunch of questions. So, Mari, I think they're all for you. So if you want to go through them.
Yeah, there was a question why combiner splitters are not used. So that's really a customer preference. Many antennas today can be made with wideband ports, so you could use diplexers. However, some customers get uncomfortable, for example, with the issue of PIM from, and one example will be combining certain AWS and PCS, or for example, in the US, band 14 doesn't necessarily play well with certain other bands. So that's one of the reasons why a lot of customers prefer to see extra arrays. And then finally, even in some cases where customers do want to combine multiple bands onto the same arrays, they may want independent tilt, and that can only be provided from inside the antenna. And so we do make products that, for example, combine European bands 1 and 3 with band 7, and then use internal diplexers to give you separate ports for each radio. So those are some of the reasons why you may see a lot of connectors on the bottom, even if there's not that many arrays inside.
There's also a question regarding what are the connectors on the pigtail side of that M-Lock jumper. So that would be typically either your 4310 that you have on your radio, if you're going to an X10 on the radio, or essentially I'll let Omar handle that as well.
Yeah, so you know better than me that we have different radios on the market, okay? So also if you look to 88R radios TDD, okay, just one variety of radio, you can find N connector, next N connectors for 310 connectors, okay? So basically the M-Lock product is available with all this kind of interfaces on the radio side, okay? So there's no standard connectors on the radio, so we have to adapt.
And Marty, there was also a question about, can you place the M-Lock along the back of the antenna instead of just at the bottom of the faceplate? Is there a design restriction for limiting that? And that may just be, if you have it on the back, now you're at a perpendicular 90-degree angle to the back of the antennas coming out. There might be some force issues, correct, with all of those jumpers?
Yeah, so I'd say so the M-Lock on the antenna side is realistically, it's just a ordered spacing of 4 standard female connectors. So it has the same, pluses and minuses as any other connector coming out the back of the antenna. So potentially you might have to look at water ingress a little differently because of the angle change. The force, I would say, is, stronger with the latch than you get, individually from single connectors of this diameter. But, potentially it could be used for that application. There's no reason why it can't be used in on a vertical face.
Okay, now we have many more questions. There is one from the chat that it's on frontal solutions. So what frontal solutions are available to satisfy the transport bandwidth from the BBU to the RH, and what are the scaling expectations? How does the beamforming feature functionality affect the future of traditional passive antenna suppliers? Does anybody want to take that?
I can handle, well, certainly we're talking about cluster connectors right now, so it has nothing to do with the frontal. So I think we need to defer that to another conversation, since that's a eCPRI related issue, and it has nothing to do with the RF cabling that goes from the radio to the antenna. Regarding beamforming for passive antenna suppliers, I don't see that there's any issues with any other supplier being able to make beamforming antennas. I mean, they're available from numerous suppliers already out in the market today. So it's just a matter of complexity of combining those TDD arrays into the FDD arrays that you already have, and making a hybrid radio product that will support both FDD and TDD. That's where those designers of those antenna products will be challenged a little bit more, because you don't have separate panels anymore that you're enabling both of those functions.
Absolutely. Well, thanks. And we have a bunch of questions, and we will go through the questions afterwards. So if there is a question that we're not able to get to, we'll contact you later and give you an answer. Now, why don't we go with the second poll? And as we do that, maybe we can take some of the other questions as well. So Kendra, can you go with the second poll?
Yes, launching the second poll now. The question is, which 5G feature is the stronger driver for cluster connectors adoption? The options are multiple frequency bands, MIMO, or beamforming.
And that's, I've been talking a little bit about this. So do you want to take some of the other questions as we wait for the results, or?
Yeah, there's a question about the pins on the metal latch, whether they're plastic or metal. Do you want to take that, Omar?
Yeah, thank you, Marty. Yeah, a lot of questions, so thanks for pointing out this one. So no, it's not metal. Okay, cannot be like really like that, just because also from a pin perspective, metal will not help for sure. Okay, we have been forced to use this one to prepare the latch on metal because of obvious reason, and we have seen that actually is not impacting badly the performance. About the housing, it's a special plastic. I see the question is about cold temperature, and it's a very valid question actually. So we went through several iterations before to get to the final design, which is withstanding very cold temperature without any problem. So it's plastic, and it's working very well also in cold temperature.
Also, Omar, I think maybe just to add on that, the actual alignment pin guides on the antenna faceplate, those are metal, correct?
Oh, yeah, of course. Yeah, of course. So we have to guarantee the perfect electrical contact. So of course the connectors here are metal. Yes, definitely.
Right, but the guide pins for the actual connector for the plastic housing to make sure that they're aligned correctly are metal as well on the faceplate.
Yeah, that's true. That's true. I'm not sure if I can show you properly, but maybe you can see there. Hopefully. Yeah.
Okay. Hey, Kendra, can you tell us what the audience thinks about 5G drivers?
Yeah, so our results are in. We have beamforming with 43% of the vote. Multiple frequency bands received 39% and MIMO received 18%.
Excellent. So is this what you guys were expecting? No comments.
No, yeah, it is. I mean, again, because
Yeah.
if we're talking trying to incorporate 3.5 gigahertz TDD as your basic function for 5G, if you're not going to do massive MIMO, then obviously that would be the primary driver. But again, frequency bands are never decreasing. So that is the obvious driver because of the migration from 2 to 4x4 MIMO, and potentially at some point in the future for the FDD world, we may get to 8x8 as well, but obviously not with a beamforming function at this point in time.
Absolutely. Okay, so let's try to see whether we have some more questions here. There is a question on weatherization, and then there is a new one about, I'm just reading it. I see it will add more connections in the RF system, which will affect the final quality of performance, which reflects on transmitting and receiving power. Do you want to take any of those questions, and then we can move on to other topics?
I might take the one about the performance and the extra connections, and I think that's a key point here is starting with the next 10 and then very focused on making sure we have a consistent connection with our latching mechanism. One of the key things is we were able to get really good return loss performance well up to, covering the entire sub-6 gigahertz band. And why that's particularly important, as someone who used to design antennas, the last thing an antenna designer wants to do is have to try to figure out how to design an extra 1 or 2 dB of return loss into the antenna to make up for, marginal return loss at the connector. And so, from an antenna or filter designer perspective, we don't want to just say, oh, we have 20 dB return loss at the connector junction. We want much better than 30 dB because we don't even want to have to think about what the contribution is at the connector interface.
Okay.
Monica, there's also a question in the chat. The question is, nowadays 5G radios are integrated radio antenna units, eliminating the need for RF connectors. Don't we think that the problem of high number of connectors and ports will be solved naturally with the evolution of this technology? And I would say right now, today, outside of China, I don't think you're going to see a substantial use of massive MIMO, and that comes from a practicality of money. If you look at how much money the mobile operators have and how many subscribers they're going to get on 5G, I think you're going to see, especially in Europe, a very large number of sectors are going to be 8x8 using the beamforming for 3.5 gig. I think in a lot of other countries, many operators are starting off with the passive antenna and radio unit, and then as traffic increases, they may migrate to massive MIMO. But right now, again, there's only a few countries that are going completely towards that massive MIMO direction. And so we'll see passive antennas around for quite a number of years.
At the same time, maybe this is more something like we were talking in the previous session about from a 6G kind of sort of a longer term evolution.
Well, definitely 4G, 4.5, and 4 point whatever G that we're going to be talking about will be around for quite a number of years. We're just looking at sunsetting 3G in Europe starting in end of this year and next year, right? So that's going to take probably at least 3 to 5 years to sunset all of 3G across Europe. And again, 4G will be around for probably until 2030. And then we'll look at where 6G takes us when we migrate over in 2030 to that new technology. So you can't assume that everything will be massive MIMO just because it's the latest and greatest technology. That assumes that every operator has unlimited amount of funds for both the OpEx and the CapEx, and that's just not realistic. I mean, the industry wants to show us what the best thing is that's out there, but that's not always what is going to be deployed at the beginning of any new network launch.
Absolutely. And So today the topic is simplifying 5G networks, but the cluster connectors is not just a 5G kind of thing. And earlier your point is that we have all the sort of massive MIMO, but today most of the stuff is 4G. So how important are cluster connectors to 4G specifically, or is it just a 5G thing?
So the reality is 4G is the first generation that introduced the idea of either a 2T4R or 4T4R radio. So fundamentally a radio with 4 ports. So once you got to 4G, maybe not the initial phases, but later in 4G, say 2014 and so on, you're already talking 4-port radios per band as opposed to 2 ports that you're seeing 2G and 3G. So that was already starting to be there. And also you saw more 4G beamforming than you did in 3G. It was introduced in 3G. 4G, you saw wider spread, and there's still plenty of places in the world that are just starting to introduce 4G AT8R beamforming today. But with also a lot of the developed countries already moving to 5G, you see more of the same. So it's a combination of 5G being introduced plus 4G either being introduced to replace 2G and 3G, or 4G just being upgraded from 2T to R to higher levels of MIMO and receive diversity.
Absolutely. Any other questions that you like to take, any of you?
There seems to be some questions on the weatherproofing. So maybe Omar,
Yes.
I don't know if you talked about the IP rating for the M-lock.
Oh, good point, Earl. Yes, there are a couple of questions, maybe 3 about that. So the point is we try to make it very simple. So once mated, it is IP68 without any extra protection. So once it's mated, there's really nothing else that needs to be done. It's really simple like that. Okay. So, and what I mean with mated is exactly what I showed you before. Just place it and fasten with the latch. That's it. Then there's another good question about the written loss. So just connecting to what Martin explained a few minutes ago. And I read, yes, written loss at a higher frequency needs to be beyond what current sub 2 gig specification. I would expect 27 dB or better. That's definitely right. So the performance of the connector at higher frequencies, so also in the TD band, or let me say also above 4 gigahertz, is better than 27 dB. I would say better than 30 dB. And so thanks for asking this question. That's definitely very important because we did a big effort in developing something that has a very good match all along the frequency. So starting from DC basically, so the same solution can be used from 600 megahertz up to 4 and more gigahertz. Hope I answered to this one. Okay. Then.
So there is the one about routing signals to the radio.
Oh, understanding with you.
The last one?
So I think that one is asking how do the mechanics work on the other side of the cluster's connector housing. So if the question is about the other side of the jumper, you have to work with what the radio OEM provides, which, as we mentioned, just looking at, say, NR78 ATAR radios could be N connectors, 4310 connectors, next 10 connectors, and the actual arrangement varies between vendor and between models of radio for each vendor. So the way we design the M-lock is we use the cluster at one end. At the other end, we need to keep the connectors free because we have no idea, where those things are going to connect geometrically compared to each other on the radio.
Right, and there's still going to all need to be weatherproofed on the pigtail end when you go to the radio. So none of those are obviously IP68. Some of them might be, but everyone's taping them anyway, so it really doesn't matter. You're going to have to tape these the 9 connector ports on the radio side, regardless of the IP68 M-LOK side of it being weatherproofed at the antenna interface.
Next thing is IP68 single port.
Yes, and a lot of things are IP68 on the connector, but that doesn't mean anyone actually doesn't weatherproof them anyway in the real world, right?
That's a great point. You know that the Next 10, the 4310 are all, I think, IP68, and trying to convince a customer that they don't need to put on weatherproofing tape, it can be a challenge.
I guess one question would be, has anyone ever seen an operator not put weatherproofing on a 4310 or a Next 10 out in the field? I've never seen one that didn't have.
Yeah, I know at least one European operator that says they've done it for multiple years now.
Well, they're probably
mandated
leading the pack then.
Yeah. It's unusual.
Yeah, I would like to ask you a question in terms of, clearly you have developed the M-LOK. Is it, how available is it to other vendors, to operators that want to, we have sort of more of an open system where they can have different vendors. So how is that going to work in terms of being available to others?
So let's say that we are definitely open to license it and actively working on this direction. Okay, definitely. So that is true. Is definitely a CommScope invention. Okay, there's no question on that. But we are working with many important connector manufacturers and jumper manufacturers in the industry or the license, of course, with I would say with very reasonable royalties, because anyhow, this is anyhow, and it seems simple, but it's an important project. Okay, it's something that took some time to be and some efforts to be developed. So yeah, we are definitely open to license it. Just taking a little bit care of reasonable royalties, I would say. Hope this answered your question.
Yeah. Going even beyond that, we fully understand the ecosystem will not support a proprietary solution. So when we talk to MNOs, the conversation is very clear that if they're going to accept M-LOK, they expect all their antenna vendors to be able to put M-LOK on their antennas, and they expect all their approved jumper vendors to be able to supply it. And so that's what we're working on is, whether we make it and sell it to somebody else to use on their end product, or we license a connector manufacturer to make connectors and sell them to other jumper antenna manufacturers. We get that, major operators believe in redundancy in the supply chain.
Yeah, absolutely. And actually,
just to complete,
yes, go ahead.
Something to add on that point, because that's an important topic as also a connector manufacturer. It's important to distinguish the accessibility of the product and being able to sell the product and somehow the royalties. Of course, the innovative company need to fund the R&D, the engineering resources and so on. So at some point, it's important that all the innovative company like CommScope and Radiall make sure that the innovation is somehow being paid by the overall market. Nevertheless, it's also important for all end customers that there are somehow competition, in the market, and the product are available from multiple suppliers. So there is something to distinguish the accessibility of the product and how to pay the innovation.
And actually, Sebastien, can you tell us, Marty mentioned the requests from the operators that clearly want to have the same solution open from different vendors. How important do you think is the contribution and what is the role of the operators in driving this? This effort from MX10, Next 10, or in general?
Yeah, I mean, at the end of the day, the operator will drive the technical choices. And for us, well, from my perspective, we have to listen the end customer and making sure that we design the right solution, the right connector from the single one to a cluster and so on. And at some point, they need simplicity. They need to also some logistic efforts. So it's important to have the same connector across multiple regions, multiple area, to make their life more simpler.
Yeah, absolutely. Okay, let's go with the final poll, so we have time to comment on that. Kendra, can you go tell us about that?
There's another interesting
Right,
question.
our last
Yeah, I
poll.
was going to say.
What is the biggest benefit from cluster connectors? We have cost reduction, shorter installation time, error-proof installation, better performance, or no benefit?
Okay, so actually, Omar, you said that you wanted to, there was a question you want to answer. Do you want to do that?
Yeah, because there's an interesting question. So do
Yeah.
cluster connector allows mechanical band before connection? How far the band has to be from the connector? Yeah, that's definitely a good question. Yes, of course, is possible to band before the connection. Okay, so you can either first fit this one, fit the M-lock in the antenna, and then start bending the coax cables. Okay. And the way you do that is simply, considering that's a standard cable. So the minimum bending radius is, 1 inch. Okay. So just keep exactly the same rules that installer have been using for years and years. Okay. That definitely can be bent, and 1 inch, I guess, is the minimum bending radius.
And I guess, could you maybe Omar, hold that up close to the screen so people can see the strain relief coming out of the connector? So
Oh, yeah.
looks like it extends about 1 inch or 1.5 inches.
Yeah, definitely. So it's that's, I guess it's 1 inch, and I don't recall on top of my mind. And that's, yes, it's exactly the strain relief. So to be sure that we are not going to stress the part in the middle that is the core of the connector, of course, where also we have the solderings. Okay, we have larger strain relief on the 3/8 variants. That's the 1/4 inch variant, but the concept is definitely exactly the same. Yeah.
Okay, Kendra, can you go and tell us what the poll results are?
Okay, the results are error-proof installation received 65% of the vote. Cost reduction received 25%. Shorter installation time received 10%. And neither better performance or the option no benefit received any votes.
Cool. And I think that that's sort of like, it's in line with what we were discussing, that, really, well, I guess shorter installation time and error-proof installation sort of go hand in hand together, because, well, if it's easier.
Well, one actually may cost you more money than the other, depending on if you took a longer time, as opposed to if you actually messed up the connection and destroyed the antenna or damaged it.
Well, and that's the thing, is that oftentimes, you look at the cost of the equipment rather than the overall cost of, if you make a mistake. And it's not just installation cost, but if you make a mistake, how much does it cost you to fix it? And that's something that is above and beyond what you see in the beginning.
I think, Omar, if you can show the pigtail side, they are labeled so that, again, depending on what the radio configuration is, the person installing it is not hopefully going to put the wrong port.
Exactly. Now hard to see on the video, but each and every port of the jumper has a label, and this label has now been standardized by NGMN. So to be sure that clusters are all named in the same way, and also port on the radio are named in the same way, just following AISG, not reinventing the wheel, really. Okay, so this is at least a tentative to minimize the issue from radio side. Of course, the cluster on the antenna side remove the issue. That's definitely the benefit. So it's not only in the time saving in the assembly, it's in avoiding the risk to have the beamforming not working, and last but not least, avoiding the risk to put the RF port into the calibration port and destroy the antenna. That is really not nice, I would say.
No, that would be a really expensive expense. So is it going to be so simple that down the line we're going to have the drones installing everything, so we don't even need humans because you made it so simple?
Well, I guess that we still need humans, luckily. Yeah, definitely.
There's also one question on the pigtails and pre-fitting. I think that came up on the other event too, Omar.
Yes.
Oh, yeah. So of course, yeah, that's a valid point. Okay, so this is not a field fit connector. Okay, definitely not. Also because CommScope tests each and every port of each and every cluster every time. Therefore, we want to be sure 100% of the quality of the product we put on the market. Therefore, the product is factory terminated. Okay, so basically, each and every customer can order the configuration they want with the length they want. And when I say configuration, means connector on radio end, size of the cable, so 1/4 inch or 3/8, and if the 4-port or 5-port. Why that? It's just because if you have a 44R antenna with M-LOK, you just need a 4-port. If you have an 88R antenna, you need the 4-port and the 5-port. So it's simple like that.
Absolutely. Sort of a high-level question in terms of adoption. You know, this is a new product. How do you see that, you know, sort of entering the market? You know, there's always a little bit of.
Yeah, that's a very valid question because you know, for every product you may find I'm product enthusiast. Okay, just look at it and say, oh, that's fantastic. I want all my antennas with this. Okay, then you may find somebody who would like to test it first, or somebody who say, okay, let's just have just few antennas like this. I want to try and see how it works, if I'm happy with it. Okay, so the good news is that so far the customers that tested it, also with small quantities, then came back saying, okay, that's a good product. I like it. Can I have all the antenna, you know, with M-LOK rather than single connectors? And that's actually a very good thing, you know, because is really the sign that customers that are trying it really enjoy it and would like to have more and more.
Yeah, absolutely. And I guess moving forward for you guys, that's a good market, because for sure this is it's a growing market by definition, because with 5G you're gonna have more ports, and you know, that's clearly the way it's going. Or do you want to comment on how is the market going to develop here? You did.
I'm sorry, Monica, can you say that again?
Yeah. How do you see the market growing for this for you know, general for connectors and cluster connectors? Because obviously, you know, with 5G we're going to need more. There's no question about that.
I think
Better, yeah.
Like the previous question that discussed about massive MIMO and the fact that massive MIMO eliminates the need for external connectors because you're just running eCPRI fiber cable from the baseband unit all the way up to the active antenna unit, or AAU. Sure, those are going to eliminate these types of connectors, but they will require a bunch of other connectors inside the unit that no one sees, that Sebastien will be very happy to sell on those types. But I think the realism is that we still have networks that are still using 2G today. They are still using 3G today. And those have been around for decades, and we're just starting to get rid of them. So 4G's been around since 2010. If we assume at least a minimum of a 20-year lifespan, then they'll be around through 2030. And the 5G passive, depending on again, consumer uptake of 5G handsets into the marketplace, it will take some years to progress from the 88R passive solutions that we have today to get to a full massive MIMO at some point down in the future. But again, that again depends on money And it depends on the operator's perspective on how much capacity do they really need, and what is the end consumer expecting to get from 5G. And I still think that's unclear at this point in time as to what their benefits are going to be in buying a $1,000 or $1,500 phone, and how much battery life are they going to get from a massive MIMO system and a network, and what applications are they going to be using. So given that uncertainty, I think operators are taking a very cautious approach right now. And again, given the impact of COVID-19 on the markets today, I think everyone's a little gun shy in wanting to go completely massive MIMO just because that's the latest and greatest technology. And because of that, I think we're going to see a lot more very complicated antennas and connector systems that will have to be developed over the next at least 5 years, if not longer, because none of these things are going away.
Absolutely. And with that note, I think we need to close it because we're at the top of the hour. So I would like to thank you all and have Kendra conclude. Thank you.
Thank you.
Okay,
Thank you.
Thank you.
great. Thank you, everyone. That will conclude our webinar for today. To CommScope for sponsoring today's webinar, and thank you to our great panel of speakers for that very interesting discussion. This webinar will be available recorded on demand and also as a podcast. Those will be available on the senseofhealy.com website, and we will send out links to all of the registrants to access those in the coming days. And please join us for future Sparring Partners on Wi-Fi 6 and Wi-Fi 6E on October 15th, and on 5G network automation on October 29th. And the registration links for those webinars will be available at senseofhealy.com in the coming weeks. Thanks again, and we look forward to seeing you at future events.